autonomous vehicle is a vehicle that can drive itself without input from a human driver. Autonomous vehicles are also known as self-driving cars, driverless cars, or robotic cars. There are several types of self-driving vehicles depending on their level of automation. These levels have been defined by the Society of Automotive Engineers (SAE), which has set 6 of them adopted by the US Department of Transportation, ranging from level 0 fully manual to level 5 fully autonomous. History of autonomous vehicle. In 1925, Francis Houdina, an electrical engineer from New York, was the first to implement the concept of an autonomous vehicle. The prototype was exhibited to the public in Manhattan, traveling about 19 kilometers between Broadway and Fifth Avenue. Houdina's vehicle, named Chandler, was built between 1926 and 1930. In the 1980s, the German Ernst Dickmann, who is considered the father of the autonomous vehicle, converted a Mercedes-Benz van into an autonomous vehicle guided by integrated computer. 1987, the car managed to travel through traffic-free streets at a speed of 63 km per hour. In 1994, it did something similar with a vehicle that traveled more than 100 kilometers through Paris in traffic. In 1995, a Mercedes-Benz traveled autonomously between Munich and Copenhagen. These projects were financed by the European Commission under the name of Project Eureka. 2021, the closest company to put autonomous cars on the market is Tesla, with their full self-driving package enabling autonomous hands-free control for highway and freeway driving.
How the autonomous vehicles work? The autonomous vehicles work based on a range of sensors placed in various places of the automobile. Autonomous vehicles will and update a map of their environment. Radar sensors keep track of where neighboring vehicles are. Traffic light detection, road sign reading, vehicles braking, and pedestrian detection are all performed by video cameras. LiDAR, light detection and ranging. Sensors use the reflection of light pulse from the environment around the automobile to calculate distances, find road boundaries, and recognize landmarks. When parking, the wheels ultrasonic sensor pick up on curbs and other cars.
4 groups of technology are employed in autonomous vehicles: car navigation system, location system, electronic map, and map matching. Car navigation system. The global positioning system and geographic information system are set up to receive location data from the satellite, such as longitude and latitude. The path planning model can also be used to program and compute the driving route using the location and destination information for the self-driving automobile. Location system. The location system's objective is to pinpoint the location of the vehicle, which can be divided into relative location, absolute location, and hybrid location. Electronic map. Digital map information is stored on electronic maps, which primarily contains geographic characteristics, traffic data, building data, traffic signs, road facilities, and etc. Map matching. The core of path planning is map matching, which determines the location of the car using both the geographic data from GPS, INS, and map data from an electronic map.
The example of implementation and application in autonomous vehicle is level 0 is no automation. Manual control the human performs at driving tasks, steering, acceleration, braking. Level 1 is driver assistance. The vehicle features a single automated system. It monitors speed through cruise control. Level 2 is special automation, ADAS, Advanced Driver Assistance System. The vehicle can perform steering and acceleration. The human still monitors all tasks and can take control at any time. Level 3 is conditional automation, environmental detection capabilities. The vehicle can perform most driving tasks, but human override is still required. Level 4 is high automation. The vehicle performs of driving tasks under specific circumstances, geofencing is required. Human override is still an option. Level 5 is full automation. The vehicle performs all driving tasks under all conditions. Zero human attention or interaction is required. Cameras with stereo vision take pictures from two angles. They take two pictures, one for the actual picture and one for the depth map. In addition to robotics, the stereo vision technique was developed for human-computer interaction while using stereo vision cameras. Has two phases. Identifying difficulties was the first step. The second stage involved improving the output outcome. They have employed individual pixels in their technique, which can degrade image quality and take more time to process. These automobiles can be used to lessen the number of traffic collisions. According to research, distracted driving among drivers is on the rise due to factors like speeding, intoxicated driving, and increased smartphone use. As a result, there have been significant losses in terms of money, life loss, and injuries sustained by people. The autonomous vehicles are intended to steer clear of collisions and interrupt traffic less frequently. Advantage and disadvantage of autonomous vehicles.
360 vision is autonomous vehicle possesses the ability to view the environment in a 360 range, reduce accidents. Vehicles being interconnected with each other and in constant communication, accidents will be significantly reduced. Although accidents will not be reduced to zero, there will be much less than accidents caused by human driving. Access to the disabled and people with reduced mobility. The automobile will be autonomous and will require practically no human interaction for its operation. Even people with visual or hearing disabilities will be able to have one vehicle. Data protection issue. The first problem that arises is in that being connected all the time with the whole environment. It can become a cyber problem of data protection. High cost of implementation. Autonomous vehicle infrastructure revolve around 5G network coverage, which is still expensive. So it may take governments considerable time to invest in sufficient infrastructure for optimal performance of autonomous vehicle. High cost of vehicle. Although significant progress has been made in reducing the cost of producing their implements, these costs are not low enough to make them a financially viable alternative for the average family.